So today we're going to review quadratics, and these quadratic functions come in a couple different forms. We have y is equal to ax squared plus bx plus c, y is equal to a parentheses x minus h squared plus k, and they both are quadratic functions. One is the standard form, the next is the vertex form. So if we're going to graph them, we have to know how to use both. We are going to find the axis of symmetry and the vertex. Now to take a look at what a quadratic looks like, we have an x and a y axis here, and if I start with my vertex at 0, 0, my function will make a parabola. So it's just kind of a U-shaped figure. We want to know where the vertex is. That's a key part. The vertex is the bottom of the parabola. I can also have a downward parabola, and so that would be the top part of the parabola. Okay, so let's take a look at a problem here. Here I have y is equal to 2x squared plus 4x minus 1. Let's find the vertex of this. Let's find the axis of symmetry, and then let's graph this. So let's find the axis of symmetry. The axis of symmetry is x is equal to negative b over 2a. And where I get the a's and the b's, a is what's in front of the x squared, so a is 2, b is what's in front of the x, which is 4, and c is the number without an x there. And so I'm just going to plug that in. So x would be negative b, so that's negative 4, over 2a, 2 times 2 would be 4. So that leads us to say that my axis of symmetry is negative 1. Now my axis of symmetry is what cuts my parabola entirely in half. So it's actually part of my vertex. So if I want, I could use that axis of symmetry to tell me how to find my coordinates of my vertex. So I know that the x coordinate would be negative 1. So if x is negative 1, could we find the vertex from there? So I'm just going to plug it into my original equation. Y is equal to 2 times negative 1 squared plus 4 times negative 1 minus 1. And I'm just going to solve that. So negative 1 squared is negative 1 times negative 1. So that's a positive 1. So 2 plus 4 times negative 1 is negative 4 minus 1. 2 minus 5 is a negative 3. So what I have here is y is equal to negative 3 and x is equal to negative 1. So my vertex will be negative 1 comma negative 3. Okay, so I can find my axis of symmetry and my vertex. The formula for axis of symmetry really comes in handy when we're trying to find the vertex also. Okay, so now what we're going to do here is we're going to complete the square. That's one of the things that we also want to learn how to do. Completing the square, we can do two things. We can solve by completing the square, or we can graph by completing the square. They're the same process with just a minor change in them. So if I want to solve by completing the square, I need to solve this, and you notice that this form here has it equal to 0, whereas graphing has it equal to y. So that's my big difference, first of all. Now I'm going to take a look here. I'm going to complete the square. Before I do that, I'm going to get rid of my number that does not have an x to it, okay? And so I have x squared plus 2x is equal to 35, and I'm allowed to do this when I'm solving. And I'm going to take half of 2. Half of 2 is 1, and I'm going to square it, and that's going to make my square. That's completing it. So I have x squared plus 2x plus 1. That's a perfect square. But since I added 1 here, I'm going to add 1 to the 35. So that now equals 36. So now I have x plus 1 squared is 36. And then I'm going to take the square root of both sides. So what I have here is x plus 1 is plus or minus 6. Now what I will need to do here is branch that off and say x plus 1 is 6, x plus 1 is negative 6, and then I will solve for both of those to get two numbers. Okay, So that's how I solve using completing the square. Now if I want to graph with completing the square, I'm going to do the same basics but change a little bit here. I want to get it to the vertex form. So what I have here is I have y is equal to this x squared plus 6x minus 7. I'm just going to kind of cut this right here, and I'm going to complete the square on this side. And then, so I take 1/2 of 6, which is 3, 3 squared, which would be 9. So if I add 9 over here, I end up with my perfect square. That's a perfect square. But since I added 9 here, these are all on the same side of the equal sign. If I add 9 here, I'm going to subtract 9 so that that balances out. So you can see that's a different part than what I had when I completed the square to solve. So -7 and -9 is -16. This is my perfect square. So it's x plus 3 squared minus 16. And this is all equal to y. So now I can look at this and say, hey, that's the vertex form. So I can say the opposite of what's in here. So -3, the same of what's on the outside, -16, there's my vertex. Okay, so I can solve that, do completing the square to solve or graph. Now, also to solve, we can use the quadratic formula. Quadratic formula, x is equal to -b plus or minus b squared minus 4, the square root of b squared minus 4ac all over 2a. And I just have to know, again, it's in the standard format. I learned my a, b, and c from there. So I'm going to plug that in. So in this example, a is 5, b is 12, and c is -2. And then I'm just going to plug it in. So to find x, I have -b, so -12, plus or minus the square root of b squared, well, 12 squared is 144, minus 4 times a is 5, and c is -2. And that is all over 2a. 2 times 5 would be 10. So now inside my radical sign, I have 144. 4 times 5 is 20, times 2 is 40, but the two negatives cancel out. So I end up having under here 184. So I have -12 plus or minus the square root of 184 over 10. And you're going to solve that, and you'll get two values for x. Okay, and so that's how we use the quadratic formula. And again, you will have to solve all of this and plug everything in to get your final answer. Okay, one last thing we're going to talk about: linear, quadratic, and exponential functions. So we have 3 different types of functions here. And so we're going to take a look at what they look like. First of all, linear functions are just a straight line. So it looks like that. Exponential functions kind of start out low and then jump up. And quadratic functions are my parabola, which is a U. So those are the 3 shapes. You should know what the 3 shapes look like. We're going to take a look at tables of data to find it. So in looking at them, linear functions have a common difference. Exponential functions have a common ratio. And parabolas, which are quadratic functions, have common second differences. So let's look at our table of data here. So if I notice here, for all of my x values, basically I'm going up 1, okay? Now for this one, if I take a look, let's start with linear because that's the easiest. Does it have a common difference? Well, to go from here to here, I go down 4, from 5 to 1, down 4, here I go down 4, here I go down 4. So that is a common difference. So this one would be linear. My next one, again, for my x values, they're all going up 1, okay? And here I have, let's take a look. Well, common difference, let's try that one first. I have from here to here goes down 2, from here to here goes up 2, up 2, from here to here it goes up 6, and from here to here it goes up 10. Now that doesn't really help me. So let's take the second difference. The second difference from -2 to 2 is up 4. From 2 to 6 is up 4, and from 6 to 10 is up 4. So that has a common second difference, so this would be quadratic. And let's take a look at my last one here. So in this case, again, my x values are all increasing at the same rate. But in this case, to go from 0.25 to 0.5, actually I'm doubling that. So that's times 2. And to go from 0.5 to 1, that doubles. And to go from 1 to 2, that doubles. So that has a common ratio. The ratio is 2. So this one would be exponential. Okay? So those are our 3 types of functions. You should recognize the pictures and you should recognize the values from the tables of data. Now that covers chapter 9, which is quadratics, and you should be familiar with all these problems. Thanks.